Okay, here we are. We are doing 2.2. Get my pencil going here. And I don't want yellow, I want black. All right, we're going to do 2.2. Now, 2.2 can sometimes be confusing because we just came out of 2.1 where x equaled a number. Everything equaled a number. And what 2.2 is all about is getting you to realize you can move things around in any type of equation. Meaning, if I had an equation that said I equals P R T, means I equals P times R times T. This actually is a formula for interest. Interest is equal to the principal times the rate times the time. But what if I didn't want to have, what if I didn't want it to be I equals? I wanted to solve for T. I wanted it to be T equals. Well, if I want T to be the one all by itself, then this P and this R are in the wrong place. They need to come over here. And the P and the R are being multiplied. So I can divide, and whatever I do to one side, I do to the other. What does that become? 1. So you're left with T equals, and what are you left on the other side? I over PR. So I solved for T. I solved for T in the sense that it's not T equals a number, but I solved for T because T is all by itself on this side, everything else on the other. Okay? All right, let's look at another one. What if I had P equals 2 times L plus 2 times W? That's actually the formula for perimeter. Perimeter equals 2 lengths plus 2 widths. But I wanted to solve for W. I want this W all by itself and everything else on the other side. Well, I got a 2 over here, but I also have something being added. So you got to do the adding and subtracting first. Meaning, I need to move this 2L over to the other side. Remember, the other side is where the equal sign is. So it's a positive 2L. So I'm going to subtract it, which gives me P minus 2L equals nothing here, 2W. All right, well, I need to solve for W, so I still need to get this W by itself. There's nothing else that needs to be added or subtracted, so now I can get rid of the 2, which is being multiplied, and divide it. But whatever I do to one side, I have to do everything on the other side. Now, 2 over 2 is 1, so that gives me my W. What does W equal? P minus 2L over 2. You've solved for W. All right, let's try another one. Okay. What if it was written like this? P equals 2 times L plus W that way. And I wanted to solve for W. Well, W is inside parentheses. I have to get rid of the parentheses before I can even isolate W. So this 2, which is on the outside and is being multiplied, needs to go away. So it needs to be divided. That makes a 1. So I'm left with L plus W on this side, and I'm left with P over 2 on this side. Now, to be able to solve for W, the only thing left I have to get rid of is this L. And the L is being added, or it's positive, so I subtract it. It goes away. I'm left with P over 2 minus L equals W. That this is on this side, this on that side. So you can leave it like that, or you can turn it the other way and say W equals P over 2 minus L. Either way is fine. All right, so why are we doing this? Let me show you. What if, let's see, do we all know that rate times time equals distance? The rate of something traveling times the time or the amount of time they travel will equal the distance they've traveled, okay? I'm going to read you a word problem. The word problem says, Nora traveled from Kansas City to Louisville with a distance of, she traveled, and the distance was 520 miles, okay? And she did it in 10 hours. They want to know, find the rate. Okay, they want to know, find the rate. They want to know what rate equals. All right, right now I don't have R equals. I have D equals. So if I could move this T over, I'd have R equals, and then I'd know what to do. Well, this T is being multiplied, so I have to divide. Whenever I do to one side, I do to the other. That becomes a 1. So R equals distance divided by time. Now let's go to our problem. If R is equal to distance divided by time, then in our problem, R is equal to 520 divided by 10, the time. This was the time. So the rate is 52 miles per hour. All right. Let's look at another one just like that. What if I said that the distance between Melbourne and London, that's a little big, is 10,500 miles. And if an airplane travels 500 miles per hour, so our little airplane, don't laugh, I can't, it travels 500, that's pretty good, miles for me, trust me, that's pretty good, miles per hour. They want to know how long will it take. So we're looking for time. Now let's remember, rate times time equals distance. We're looking for how long, so we need to isolate our T. We need to get rid of the R, which is being multiplied. So we divide, and whatever we do to one side, we do to the other. So R over R is 1, so we get time equals distance divided by rate. What was the distance? 10,500. And what was the rate? 500 miles an hour. So how long did it take them? I don't know, I gotta get a calculator. 10,500 divided by 500 should be about 200 and, no. There you go, 21. And I was gonna say 21, I came up to a 10, okay. 21, so how long did it take? 21, because these were miles per hour, so it took 21 hours. That's a very long airplane trip. All right. There will be a few more problems like this in this section that deals with applying. They give you the formula, or they give you the problem, and you have to figure out the formula, isolate the variable, and solve for it, okay? Some of the formulas you might have to look up. You might not know them, like the circumference of a circle or the diameter of a circle, things like that. But there's just a few, but they're fun. They're fun. All right, that was 2.2, and we're done. So you guys have a good day.